हेलो गाइस, वेलकम। तो इस चैनल में आप लोगों को जो है CSIR नेट गेट या फिर जैम का जो है वो टॉपिक पूरे बेसिक के साथ इस चैनल में आपको मिल जाएगा। जो कि पहले हम लोग CSIR नेट का जो है सिलेबस देख लेते हैं, वो क्या क्या है। पहला जो है वो है रियल एनालिसिस, दूसरा जो है कॉम्प्लेक्स एनालिसिस, तीसरा लीनियर अलजेब्रा, एब्स्ट्रैक्ट अलजेब्रा, थोड़ा सा टॉपोलॉजी भी है। उसके बाद ऑर्डिनरी डिफरेंशियल इक्वेशन, पार्शियल डिफरेंशियल इक्वेशन, न्यूमेरिकल एनालिसिस, कैलकुलस ऑफ वेरिएशंस, इंटीग्रल इक्वेशंस, क्लासिकल मैकेनिक्स और थोड़ा सा एलपीवी भी आता है और स्टैटिस्टिक। तो ये जो है ये पूरा नेट का सिलेबस है। तो नेट और गेट का जो है वो सिमिलरिटी है। CSIR नेट का पढ़ लेते हैं तो आप लोग गेट और जैम तो आप निकाल ही सकते हैं। तो चलिए सबसे पहले आज हमारा जो पहला टॉपिक है वो हम कॉम्प्लेक्स एनालिसिस के बारे में पढ़ेंगे, जो कि पूरा बेसिक से पढ़ेंगे और आप लोगों को लास्ट तक इसका जो है वीडियो आप लोगों को इस चैनल में मिल जाएगा, जो कि आपको नेट निकालने में आपकी मदद कर सकता है। तो चलिए आज का वीडियो स्टार्ट करते हैं। सो टुडे वी विल स्टार्ट कॉम्प्लेक्स एनालिसिस। सो कॉम्प्लेक्स नंबर z, complex number denoted by z, and this z equal to x plus iy, where x and y are belongs to R, that is set of real numbers. This I, this symbol I was discovered or was found at 1797 by Euler. And complex number system and complex number system and complex number system is established at 1833 by Hamiltonian. And now this axis for a complex number, that is z, that is real axis, and this is imaginary axis. So in real we know that this is x-axis and this is y-axis, but in complex this is real axis and this is imaginary axis. If z be any complex number, that is point here, that is x plus iy, that is in order pair xy. So this distance is y and this distance is x. Now and in complex number system, that is complex analysis, this plane is known as Argand plane. So in complex plane, in complex number, that is complex analysis, this plane is known as Argand plane. Now some properties for complex number, that is if a plus ib plus c plus id, then this will be a plus c plus I of b plus d, that is real sum with real and complex, that is imaginary part sum with imaginary part. So this again property number 2, a plus ib into c plus id. If there are multiplication, then we have multiplication this, we have to multiply to this, then ac plus iad, this ibc plus this I square, that is value of I square. We know that the value of I square is -1. Value of I square is always -1. So this minus bd, so this will be ac minus bd, that is real part, m plus I of AD plus BC, that is imaginary part. Now, and important note, that is complex number is always unordered pair. This is always unordered. The real numbers are ordered, but complex number is always unordered. Now we have to learn, that is argument. What is argument? So that is argument of a complex number. Argument of complex number. Here question arises, what is argument? So what is argument? So argument is an angle on the of that complex number with respect to the positive real axis or x-axis. So now that is here alpha with the angle of that number, this with real axis, that is positive real axis. So alpha will be tan inverse mod of y by x. This is alpha, and the range of alpha is here 0 to pi by 2, that is 0 to pi by 2. So range of alpha is 0 to pi by 2, that is 90, 0 to 90. Now argument of the z, that is argument of the complex number z. This is real, this is imaginary. So if the complex number is point here, then the argument will be alpha. In this plane, then will be minus alpha. In this plane, then will be minus pi plus alpha, and this plane is pi minus alpha. So one chart is here. This is the chart. So this is important. So the argument of z, that is a complex number, and is its argument will be 0. In which plane? If x greater than 0 and y equal to 0. If there is y equal to 0, then it will be real axis. So here angle will be 0. And alpha, and where alpha? Here we see that this plane, that is real axis, that is real part greater than 0 and imaginary part greater than 0. Then the argument will be alpha. Pi by 2, in which if x equal to 0 and y greater than 0, pi minus alpha, this is pi minus alpha, that is imaginary part greater than 0 and real part less than 0. So x less than 0, y greater than 0, and pi, where y equal to 0, that is real axis, and x less than 0, then this will be pi. And minus pi plus alpha, this real part negative, imaginary part negative. So x less than 0, y less than 0, and minus pi by 2, x equal to 0, y less than 0, and minus alpha if x greater than 0, that is real part greater than 0 and imaginary part less than 0, that is x greater than 0, y less than 0. This is the argument, and this argument is known as principal argument. And here another argument is general argument. This is general argument. General argument is that the principal argument and with sum 2n pi, that is f. So general argument is denoted by small a arg of z. It will be capital argument of z, that is this argument, that is principal argument, plus 2n pi for all n belongs to set of integers. So this is the form of general argument. तो हम लोग कुछ एग्जांपल देख लेंगे जनरल आर्गुमेंट और प्रिंसिपल आर्गुमेंट के बारे में। तो चलिए, फाइंड द प्रिंसिपल आर्गुमेंट ऑफ z इक्वल टू 1 प्लस आई। तो हमें z कॉम्प्लेक्स नंबर दिया हुआ है, तो हम जानते हैं z इज इक्वल टू x प्लस आई वाई एंड z इज गिवन बाय 1 प्लस आई वाई। सो x plus iy is equal to 1 plus I. Now real and imaginary part, we have to compare this. So then we have x equal to 1 and y equal to 1. Now we show that alpha is equal to tan inverse mod of y by x. So tan inverse y, that is 1 by x is 1, so 1, so it will be tan inverse 1, and tan inverse 1, this is pi by 4 radian. So here x greater than 0, that is positive, y greater than 0, so there will be only alpha. By chart we have there is only one, that is alpha. So the argument, principal argument is pi by 4. Another example, that's another question is z equal to minus 1 plus 4i and find its principal argument. So again z equal to is x plus iy, so we have x plus iy is equal to minus 1 plus 4i. So we have x equal to minus 1 and y equal to 4. Then we have to calculate the alpha. This is alpha. This is alpha equal to tan inverse mod y, that is 4 by minus 1. So this will be tan inverse 4, because that there is mod, so minus will be also positive. So and tan inverse 4, its value will be 104 degree. And here see that x is less than 0, that is in which plane it's occur. This is here alpha, this is here minus alpha, this is minus pi plus alpha, and here my pi minus alpha. So this is x less than 0 but y greater than 0, so x less than 0 this, and y greater than 0 this, so this will be the argument of z. So hence argument of z will be pi minus alpha, that is pi minus 104, and this will be 180, that is value of pi. We always know that 180 degree minus 14, so it will be 76 degree. Now this is degree and we have to calculate it in radian form. So we all know this multiplication with pi by 180, and we have 19 pi by 45, because for 19 and this for 45, 19 pi by 45 radian, and this will be the principal argument. So we learn principal argument. Now we have to learn that is general argument. What is general argument? General argument's form is as it is denoted by small a arg of z. This is equal to argument of z, that is principal argument, plus 2n pi for all n that is belongs to set of integers. This is the form of general argument. So there are one example of general argument. So if z equal to same question 1 plus I, then what is the general argument of z? So again here we have x equal to 1 and y equal to 1, comparing with a real and imaginary part. So again alpha is equal to tan inverse y by x. So this we have tan inverse 1, this is equal to pi by 4. This is the argument and this is the principal argument. Then what is the general argument? Then arg, that is general argument of this, is equal to pi by 4 plus 2n pi. This n belongs to z. So this is the general argument. So now note down one note. Principal argument is single valued function, and note number 2 is general argument is infinite valued functions. So this is to note. Now there are another application is logarithm, that is principal value of logarithm and general value of logarithm. So now here we note, that is underline principal value of logarithm. So what is this? So we know that z is equal to x plus iy, that is real number, complex number. So the log, that is capital L, log for capital L, log z is will be ln of mod z plus I into argument of, that is principal argument of z. This is the logarithm principal value of logarithmic. And general value, what will be? That is general value is that there are, that is log z is equal to ln mod z plus small argument of z, that is general argument of z. So this is the difference between logarithmic, principal value of logarithmic and general value of logarithmic. They are same, but here for principal value here will be principal argument, and for general value there will be general argument. And we know that what difference between principal argument and general argument. So this example, that is previous example, we consider, that is z equal to 1 plus I, then the logarithmic value, that is principal value of logarithm, what will be? So we know that by previous example or previous calculation, that is argument of z is equal to pi by 4. So logarithmic of z is equal to ln of mod z plus I of pi by 4. So what will be the mod z? Mod z is known as if z equal to x plus iy, then mod of z will be the root over real part square plus imaginary parts is square. So there is mod z, that is ln of mod z means 1 square plus 1 square. So root 2 plus I pi by 4. This will be the principal value of this principal value of logarithmic z. And its general value, what will be? Its general value will be same as log z is equal to ln root 2 plus I of pi by 4 plus 2n pi. So n belongs to set of integers. This will be its general value, this will be principal value, and this will be general value. So another application, so there are another application is exponent. There will be one question given, that is what is the principal value of that, that is if z1 and z2 be two distinct complex number, then what will be the principal value of z1 to the power z2? So it will be nothing but it will be e to the power z2 log z1. So we can written as this, because e to the power log z1 to the power z2, that will be z1 to the power z2. So this can be written as this, or this can be written as this. So hence, if the question will be given what is the principal value of I to the power I, then there are formula, this exponent formula will be applied. So this example we have to calculate here, z1 is equal to I and z2 is equal to I. So now log of, that is, this is log z1, so log z1 means I, so it's log, that is principal value of logarithmic. So we read as so we learn the formula is ln of mod I plus I of, this is principal value, so principal argument. So now on this we know that its mod value, but we have to calculate now argument of I. So what will be the argument of I? So here z equal to I, so it can be written as 0 into 1 or 0 plus I into 1. So here x is equal to 0 and I is equal y is equal to 1. So argument, what is the argument? Argument is it nothing but alpha is equal to tan inverse y by x. So tan inverse y means 1 and x is 0, so this is does not exist or undefined, so tan inverse this will be infinity, so tan inverse infinity value gives us pi by 2. So what we have here the argument of I is equal to pi by 2. Now so we have log of z1, that is log of I, we have here ln of mod I plus I of pi by 2. Now this mod is 1 because its real part is 0, that is I can be written as 0 plus I into 1, so x is 0 and y is 1, so its mod value, that is root over 0 square plus 1 square, so 1. So ln 1 plus I pi by 2, and ln 1 is, we know that this its value is 0, so I pi by 2. So we know that the log of z1 is I pi by 2. Now z2 log z1, what will be that? Z2 means I and log z1 means I, so I now log z1 log I value is this I pi by 2, so I into I pi by 2, so it's I into I, that is I square pi by 2, and I square value is minus 1, so minus pi by 2. So now what we calculate? We have to calculate I to the power I, so its value is, that is formula, e to the power I log I. Now its value, so this is I log I, this I log I value is minus pi by 2, so it will be e to the power minus pi by 2. So this is the principal value of I to the power I. Another method is, if there are given I to the power I, there are I to the power I, so we know that I is equal to 0 plus I into 1, and we know that the cos value, that is cos pi by 2 is 0 plus I 1, sin pi by 2 is pi by 2, so it's this is the expansion of e to the power I pi by 2. we know that e to the power I theta is cos theta plus I sin theta. So cos theta plus I sin theta is e to the power I theta. Now so this is therefore I, so e to the power I pi by 2 whole to the power I, so this is e to the power I into I pi by 2, so it will be e to the power minus pi by 2. Here are this method and this method. There are two methods. So there are one question is, this is homework for you, that is I plus I, 1 plus I to the power 1 minus I. What will be its principal value? Find its principal value. This is homework. Hints, there are some hints are, if you take z1 is equal to 1 plus I and z2 is equal to 1 minus I, then you know that the formula z1 to the power z2. Another example, there's another problem is for principal value. So find the principal value of minus 1 to the power 2I by 5. So here we can apply z1 to the power z2, but there are some easy method is this. So minus 1 is to the power minus 2I by pi. So we know that the minus 1 can be written as this cos pi plus I sin pi. So cos pi is value minus 1 and sin pi is 0, so there will be minus 1 only, so it's can be written as e to the power I pi. We always we know that this is can be written as e to the power I pi. Now this minus 1 to the power this, so minus 1 we can be written as replace as, so here minus 1 to the power minus 2I by pi, so minus 1 can be replaced by e to the power I pi, so e to the power I pi to the power minus 2I by pi, this power, so we have e to the power I pi minus into 2I by pi. There are pi cancel, so we have e to the power minus I into 2I. So there are another, this is I into I, that is I squared is minus 1, so plus, so minus 1 and this minus, so minus 1 is plus, so there will be only 2, so its principal value is e square. So we complete this principal argument, general argument, exponent and principal value of logarithmic. Now this is conjugate. What is conjugate? So if z is x plus iy be any complex number, but then its conjugate is denoted by z bar. So this z bar is means x plus iy its whole bar, and its x bar plus I y its bar. Now x bar, since here x is real number, so x bar is always x plus this are multiplication. We know that the property of conjugate, that is I bar into y bar. So x plus, we know that the I bar it's minus I and y bar, y is a real number, so it's y, so x minus iy. So conjugate of any real numbers, that is z, is equal to x minus iy. So if z is x plus iy, then its conjugate will be x minus iy. That is example, if z is equal to 2 plus 3i, then conjugate of z it will be 2 minus 3i. So this is conjugate. The property, the important property, it's one, if z1 by z2 its whole bar, then it will be z1 bar by z2 bar. This is one where z2 is not equal to 0, then it is valid. So number 2, if z bar it's to the power n, then it's zn to the power this whole bar. So now, and this the third property is z multiplication z bar, it will be mod z its whole square. So mod z square it's equal to z into z bar. These are the property of conjugate. Now there are another application is finding nth root of a complex number. So finding nth root of a complex number. Now to find the nth root of a complex number, we have to learn another statement, is the name is de Moivre's theorem. De Moivre's theorem. What is this? If cos theta plus I sin theta it's whole to the power n, then by this theorem we have to replace it or written as cos n theta plus I sin n theta. This n will be multiplication with theta. Now this de Moivre's theorem statement. So now we know that z equal to x plus iy be any complex number. So in polar form we have to write in polar form x is equal to r cos theta and y is equal to r sin theta. So then z will be its r cos theta plus I r sin theta. So there are r will be common, so r cos theta plus I sin theta. Now z to the power 1 by n, that is nth root, so taken power both side, it's 1 by n, so it will be r to the power 1 by n and cos theta plus I sin n theta, it's to the power 1 by n. We have z to the power 1 by n, it's r to the power 1 by n cos theta plus I sin theta whole to the power 1 by n. Here cos theta and sin theta is periodic function and with period is 2 pi. So we can written as cos theta plus 2k pi plus I sin theta plus 2k pi. Here k is the integer, that is k is integer. So now then r to the power 1 by n, it will be cos 2k pi plus theta by n by de Moivre's theorem. This theta by n. So this is the nth root. Here for k equal to 0, 1, 2, n minus 1, we have to find its nth root or its root. There are another example is, and here k is equal to 0, 1, 2 dot dot n minus 1. This is n, so it will be n minus 1. If there are 5, then it will be 0, 1, 2, 3, 4. So this is example. What example is, find the cube root of 1. So z is equal to, that is z cube is equal to 1. So it will be z is equal to 1, this 1 to the power 1 by 3, and 1 can be written as cos 0 plus 2k pi, since cos 2 pi is 1, cos 4 pi is 1, so cos 2k pi, and this is 0, this is for theta, plus I sin 0 plus 2k pi, this whole to the power 1 by 3. Then by de Moivre's theorem we have cos 2k pi by 3 plus I sin 2k pi by 3, where k is 0, 1 and 2, because there are 3, so k will be 0, 1 and 2. Now if we calculate for k equal to 0, then we have what we have. This is we name is omega, that is one root is omega 1. This is cos is 0, so cos 0 plus I sin 0, cos 0 is 1 and sin 0 is 0, so it will be 1, so one root is 1, so one root is 1, another is omega 2 for k equal to 1. What will be that? This will be k equal to 1, so cos 2 pi by 3 plus I sin 2 pi by 3. What its value? Its value will be cos pi minus pi by 3, and you can put its direct value, plus I sin pi minus pi by 3. So cos of pi minus pi by 3, it's minus cos pi by 3 plus sin of minus sin pi by 3, its value is sin pi by 3. So minus cos pi by 3, it's minus half, that is cos pi by 3 is half, so minus is here, and plus I sin pi by 3, it's root 3 by 2, so it will be 1 plus root 3 by 2. This is the omega 2, and the homework for you, this is k is equal to 2, that is W3. It's your homework, calculate it. So there are some problems. This is find the value of root 3 plus I whole to the power 7. What is its value? So here let z is equal to root 3 plus I. So we suppose this is z. So now some operation will be there, root 3 by 2 plus I root 2. There are what we have? We have divide by 2, so multiplication by 2, that's then it will be balanced. So this is z. So now 2 into cos, this is root 3 by 2. What will be the value of this in cos or sine? So this is cos pi by 6, cos pi by 6 value, it's root 3 by 2 plus I into half, so sine pi by 6. Now what we have? Now we have that is we have to calculate this value, so this to the power 7, so z to the power 7 means root 3 plus I whole to the power 7, so this is equal to 2 to the power 7, this is here z, so this is 7, and cos 7 pi by 6 by de Moivre's theorem plus I sin 7 pi by 6, so 2 to the power 7, so 7 pi by 6, cos 7 pi by 6 is 5 plus pi by 6, so it will be minus cos pi by 6, so minus cos pi by 6 is minus root 3 by 2, and sin 7 pi by 6 is sin of pi plus pi by 6, so minus sin pi by 6, so it will be also minus I into half, that is I by 2, so this will be 2 to the power 7 into minus root 3 plus I by 2, So now 2 to cancel, so here 2 to the power 6, this is minus is outside, so this will be the value of z to the power 7. This is one example. There are another example is if omega be the cube root of unity, then find the value of a and b such that 1 plus omega whole to the power 7 is equal to a plus b omega. This is given. Solution. What is given? Given is omega be the cube root of unity. So we know that if omega will be the cube root of unity, then omega cube is equal to 1, and this is condition 1, and 1 plus omega square is equal to 0. These two conditions. And here what we have, 1 plus omega whole to the power 7, this is equal to a plus b omega. Then we have to calculate the value of a and b. So now from here we have 1 plus omega is equal to, this will be here, so minus omega square. So we can replace it, minus omega square whole to the power 7. So this will be a plus b omega. So now minus 1 to the power 7, so this will be minus, and omega to the power omega square whole to the power 7, so it will be omega to the power 14 is equal to a plus b omega. And we know that omega cube is equal to 1, so here we write it in form of omega cube, then its power. So minus, if we will take omega cube into to the power 4, then it will be 12. Then there are another is, this is omega square. Okay, so omega to the power 12 and into omega square, this will be a plus b omega. Just we break it, just omega to the power 14 and break it this. So we know that omega cube is equal to 1, so 1 to the power 4 is 1, so minus omega square is equal to a plus b omega. Again what we have, 1 minus omega square, this from here minus omega square we have 1 plus omega, so we can replace it, 1 plus omega, it's equal to a plus b omega. And then we compare with the coefficient, then we have a is equal to 1 and b is equal to 1. This omega coefficient is here b, and omega's coefficient is here 1, so a equal to 1 and b equal to 1. So now we have to learn this symmetric point. So what is symmetric point? Symmetric points, there are two names. Symmetric point is known as conjugate point, so it's conjugate point, and this is inverse. So symmetric points, the other name is conjugate point and inverse point. So what is that? So if C be any curve, so C be any curve in the complex plane, so if C be any curve in complex plane and z1 z2 be two distinct complex number, so C complex प्लेन में कोई भी कर्व है एंड z1 z2 तो कॉम्प्लेक्स नंबर है डिस्टिंक्ट, then we have to say Z1 is said to be symmetric point or conjugate point of Z2 if Z1 is the image of Z2. So C complex square may C be any curve in complex plane and Z1 Z2 be distinct complex number, then Z1 is said to be symmetric point, conjugate point or inverse point if Z1 is the image of Z2. So by graphically, what is that? So this is real axis and this is imaginary axis, and there are one curve. We say this is C, that is y equal to x be any curve. Now Z is here x plus iy, then its image it will be here. So then this point will be the symmetric point of this. So there are one example of symmetric point, conjugate point or inverse point. So if C be any curve, that is y equal to x and Z1 is equal to 2 plus 3i, then what will be the conjugate point of Z1? So here Z1 is equal to 2 plus 3i. So from here we have x equal to 2 and y equal to 3. So and the curve is y equal to x. So y and x will be same. So Z2 is equal to 2, that is 3, x tends to y and y tends to x. So in conjugate point this is image, so they will be changed in their position. So this will be 3 plus 2i. So this will be the conjugate point of Z1. So symmetric point with respect to a circle. So if the curve is given as a circle, then we have to calculate the symmetric point of that complex number. So this, let the equation of a circle in complex analysis, it will be this, where alpha will be the center and r will be the radius of the circle. Now this is organ plane and this is the circle, and now P and Q, that is here P and this is Q, and P and Q be 2 points. This is the organ plane and this is the circle, and P and Q be 2 points on the organ plane. So now, and the center be its we take C and its radius is r, because this is the equation of a circle. So now then P and Q, this point will be called the symmetric if number one condition is, what is that? And this is C, P and Q both will be collinear. C, P and Q are collinear, that is they will be in one plane. Okay, then condition number 2, what is that? This is P and Q will be the same side of center, and these points that's P and Q lie on the same side of the center. And the third is CP into CQ, this will be r square. So what is that? This is P and Q be 2 points on the organ plane, and they will be the symmetric point of with respect to circle mod z minus alpha is equal to r if c, p, q are collinear, p and q lie on the same side of the center, and at last this cp, this distance, into cq, this distance, it will be the r square, that is radius its square. Then we say that p and q with a symmetric point. So now this is formula to find the symmetric point with respect to a circle. If z1 is given, and a circle, that is z minus alpha, this curve is also given, then what will be the z2? The z2 will be alpha, that is center of the circle, plus, that is radius square, by these numbers, this z1, so here will be z1 bar minus alpha bar. So this alpha will be the center of the circle, r is the radius of the circle, and z1 with the given complex number. So there are one example, we have to see one example for this formula. So here gamma, that is c, is given as, that is a curve is given by z minus 1 is equal to 1, and z1 is 1 plus I. Then find z2, that is symmetric point of z1. So here this is z minus 1 is this given. So here alpha, that is center of this curve is, that is circle, is 1, so alpha is 1 and r is also 1. Now z2 will be, what is that z2? Z2, that is alpha, so alpha is 1 plus r square, that is here r is 1, so 1 square by, that is z1 bar. What is z1? Z1 is 1 plus I, so 1 plus I its bar minus alpha bar, alpha is 1, so 1 bar. So here this will be 1 plus 1 square is 1, that is the conjugate point, so 1 minus I, and 1 bar is 1, so it will be 1 plus 1 by, this is my 1 and 1 is cancelled, so minus r will be there, so 1 minus 1 by I, and then after calculating we have 1 plus I, that is the symmetric point of this point. So one note down, so what is that? A point which lies on the curve is called self conjugate. What is that? If a point which lies on the curve, that is this with a circle, and if one point is here or here or here, that is on the curve, that is surface on the curve, then this point will be the self conjugate. So there are another example is, if c is given as z minus 2 plus 3i is equal to 5, and z1 is equal to 2 minus 3i, then find z2. So what is that? Here z alpha will be there, so here alpha, so minus z minus 2 minus 3i is equal to 5, so here alpha will be 2 minus 3i, and r is equal to 5. Now z2, what is the formula? Formula is alpha plus r square by z1 bar minus alpha bar. So now this will be alpha. Alpha, what is that? 2 minus 3i plus r square, that is 5 square by z1 bar, that is z1 bar, this 2 minus 3i bar minus alpha bar. What is the alpha? Alpha is 2 minus 3i its bar. So here 2 minus 3i, this minus this, so this will be 0, so 25 by 0, so it will be infinity. So the symmetric point of z1 is infinity. Okay, so here we stop the complex number system chapter, and in the next video we learn about the function of complex number and its limit, continuity and differentiability. So thank you, and like, share and comment, and subscribe my channel for more videos.